Hello everyone, I am Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today in this video we will discuss about Carey Foster Bridge. What is Carey Foster Bridge? How it is derived from Wheatstone network, and what are the applications of Carey Foster Bridge? Through this Carey Foster Bridge, what we are going to determine by using the experimental setup. So these are all the things we will discuss in this video. So let's go into the video. So in this video, we will detailedly discuss about Carey Foster Bridge. So actually, this is a lecture series video. So in this lecture series, we are continuously discussing about current electricity and its applications. So today we will discuss about Carey Foster Bridge. So the Carey Foster Bridge, it is based on the principle of Wheatstone Bridge, that is used to compare two nearly equal resistance and determine the values of lower resistance and the specific resistance of a particular wire. So this is the experimental diagram for setup for Carey Foster Bridge. So this is actually it is used to determine the low range resistance values of a particular or coil, whatever it may be. We can find out the resistance. So in this diagram, there are four resistors are connected: R, X, Y, Z. So in between R and X, we have connected the EMF, that is battery. Then switch is connected in the negative of the battery, and switch is again connected. Another end of the switch is connected in between the Y resistance Y and S. So and A and B is there. In between there is 1 meter wire is connected, that is the Carey Foster Bridge setup. And the galvanometer is connected with the jacky, and one end of galvanometer is connected with the jacky, and another end is connected in between X and Y resistance. So this is the experimental setup for Carey Foster Bridge. So this is based on the, already we have discussed about that, this is based on the Wheatstone network. So here the experiment setup is there. So we have taken, once the circuit is completed, you can take in the readings. So the procedure for the Carey Foster Bridge is, first we have to keep the resistance R in left hand side and S in right hand side. Then we have to move the jacky from point A to B. So in between it will balance in a particular distance in the length of the wire. So then if we have to note down the readings, then again we have to interchange the resistance R and S. So we have to keep the resistance S in left hand side or in right hand side. Again we have to repeat the same procedure to take the reading. So we have taken two set of readings. Then the equivalent circuit will be for the both circuits is this is the equivalent circuit for the Carey Foster Bridge. We are keeping R is in left hand side and S is the right hand side. So this is the first circuit, it shows the equivalent circuit for the particular setup. Then second circuit shows the equivalent circuit for the second setup, that is S is kept in the left hand side and R is kept in the right hand side. So this is the Wheatstone network diagram. So from these two circuits, and we have built some equations and finally derived the equations from these circuits based on using the Ohm's law and these Wheatstone network calculations. So this is all we have utilized in this calculation. Finally we'll get the unknown resistance value, or that is equal to S plus rho into L2 minus L1. So this is the final equation to find out the resistance value. Then the applications of Carey Foster is given. Some of the application is given here. That is the application of Carey Foster. That is, it is used to calculate the values of medium resistors. So medium resistance we can calculate through the Carey Foster bridge. So it is used to, again it is compared to approximate values of equal resistance. We can compare with this application. We can compare two resistance values. Again it is used to measure the value of a specific resistance of a solid wire. So that is used in the light detector circuits. We can measure. Then again it is used to measure the intensity of light, pressure and strain, since it is the modified from of that is a modified form of the Wheatstone network or Wheatstone bridge. So these are all the some applications of Carey Foster bridges. So this is the advantages for Carey Foster bridge. One of the these are some advantages we have given here. So the complexity of the bridge circuit is reduced because of there is no need of additional equipment except the slide wire and the resistances. So we need only four resistance and wire, 1 meter wire and jacky, and for the measurement that we have used the that is the galvanometer. Like that we are using the balancing to know the balances. So again it is it can be utilized as a meter bridge where the slide wire length can be increased. So if increase the length of the wire means by connecting resistance in series, hence the accuracy of the bridge is increases. If you increase the length, again the accuracy also increases. So the construction, next one, construction is simple and very easy to design. So very simple circuit. So that's what the main advantage of this Carey Foster bridge. Then the components used in the circuit are not complex. So very simple electronic components are utilized here to calculate the unknown resistances. So thank you for watching this video. So we'll continue in the next video in our lecture series. Thank you.